Alright, now this is Hello World Part 3, and this is mostly on pointers. So I'm just going to run through this and step through it, and you can kind of look at what the results are, and I'm not going to explain it too much. I just want this to be rather quick. Okay. So you just observe what it's doing. Here we change the base of our cout like we did in the last video. I'm just really doing a lot of things with pointers here, redirecting them, and you can see the addresses of the pointers. And I'm dereferencing it to show what it's pointing to. Like I said, pointers have to be declared with their, the same base type, so you have to have a string pointer pointing at a string object, a double pointer for a double object, an integer pointer for an integer object. So it knows how much space to reserve for it, because you're stuck at that space. You can't, I can't change this from an integer like a character, for example. It's always got to point at a similar data type, even though you can point the pointer, though, to anywhere you want in memory. Just remember that. You don't have to point it at a type. You can, in theory, point it at an address, although I don't think I've ever seen that done, but I can't remember if I've tried it or not. But the only catch is it does have to point something. You can't just assign it to a text object, and have it not be a string or a double in this case, or an integer in this case. But once you pointed it somewhere, you can offset that, almost anywhere from that initial location. Let's see what's going on here. Okay, now we're going to be looping through a pretty big array, so let me jump over that. Execute it. Okay, so it won't output anything, but it's populated an array, and I'm doing this without pointers. Now it's going to print it out. So just jump there. And I will. Well, let me just go ahead and execute, because I don't know what this is going to do. Yeah, printed out, all this stuff here, so. Get kind of up here. So even right here, you can kind of see that some of these locations didn't have anything in them, because this is just garbage data. So our array ended somewhere, around here. Then we started to print out garbage, because I did, to 55, even though we only put an array in there of 50. So it shows, like I said, there's even in an array, there's no bounds checking on it. So you can overshoot the array. In Visual Basic, you try doing that, it'll give you errors, for subscript out of range, that kind of thing. Or at least I think it used to. Okay, now to use the pointer. Okay, so let me clear this. And, because basically, I set the pointer equal to the nums array. And I didn't have to use an address of operator here, because a num array is a pointer. So I'm really just setting one pointer equal to another pointer. So that's why I was able to do that. And you can see all the stuff this printed out. So pointer address, you know. So let's see. Because see here, I'm actually using pointer arithmetic, which is usually shunned upon. It's this is really considered bad practice in programming, but to use pointer arithmetic too much, believe it or not. But at any rate, you can post increment it, and then or just reading the values. But like I said, conversely, I could have used an array notation, the brackets, and just did it as an offset from that original value. In other words, a pointer can work just like an array. So I could have gone through a loop here, and set the pointer, just left the pointer set to it where it was originally at, and then just used the array notation like I did with this pointer here, the nums array. I could have done it exactly like this with this pointer, and it wouldn't have bothered it at all. So, in a later area, I think I look into that. One of my more recent files, so it'll be a while in the tutor because these are, we're still early on in this. Got text arrays here. Where the fuck was that declared at? Oh shit. Peak definition. Line 53. Oh shit. Yeah, of course. Just because it's in yellow, I don't recognize it. Okay, so that's where we're declaring text array, and I'm setting it equal to all this shit. And it is a text array of various, snippets of text. Then I'm going to set a pointer equal to it, obviously, and show that it works just like a character array, although it is a string object. So that's a little different. But what this is a text array, so I am, but it's actually a string array. So this is an array of string objects. So actually what we're doing is we're pointing the pointer to an array of objects, so of width string. So now if I'm not mistaken, because again a string object, can be variable size, obviously, because it can deal with variable size strings, etc. Some of these could be 1,000 characters long. But I think when you create an array of that, it actually creates like a lookup table, in the array, and that's why we're able to assign a pointer to it. And remember, this is still a pointer too, and it's going to be of some fixed length, but it'll probably, it might be an offset table entry length, so it might be just an array of addresses to these actual string objects wherever they are actually sitting in memory, because again these are going to be variable size, because each string object you create can be a different size because of the size of the array can be different. So, and they're dynamic, so they don't have to be known at runtime or anything. So that would be my guess, that in order to make this a uniform array and to be able to assign a pointer to it on top of that, which is a string type pointer, it's got to be, if we declared way the fuck up here, somewhere. right here, string type pointer. So I initialized it, by setting it equal to the text, address of text. But yeah, I mean, I'd imagine that's a lookup table, and that's why it's, it works. So again, we're not pointing at the actual object, but a reference to an object, because it's, a lookup table. So it's like a starting point. So it's probably an array of pointers. Is probably what this is as another alternative, because that could actually be creating an array of pointers, and each pointer, creates, has a reference to where the actual object is. That would make sense, for text array to be like that. And then when you point a pointer at the array, okay, you're actually pointing a pointer at the starting position of an index of pointers. That would make more sense than anything to me. So, so we got a pointer basically pointing to an array of pointers. So of width string. So these are string width pointers to string objects. That's probably how it's working. It's either that or, like I said, it's some kind of lookup table. So I'm not entirely sure which, but it's just a theory. So that's one of the things that's actually confusing me. I mean, how the hell can a pointer be pointing to an object like that that's going to be a variable size, because these are all variable width strings. So, and again, some of these could be hundreds or thousands of characters long. I mean, they don't have to be just like little short strings. String objects can hold a shitload of characters. It might even be a billion, 4 billion, might be limited by an integer type. I'm not sure. I just know they're huge. Okay, so what are we doing here? Can't handle the total bullshit in this shitty language. Fuck this stupid idiot language. Anyway. Okay, now you can see what I'm doing. I'm incrementing the pointer. Again, pointer arithmetic. It's part of pointer arithmetic. Right output. Okay, that must be a function we defined. There's a few functions that are defined later on. Okay, current value, compute triple, and reference function. So it must be doing pointers to functions later on. So you're passing by reference here, which is more appropriate. RABC, looks like you're using Hungarian notation here. Okay, passing the pointer into this, but that pointer is freely modifiable. There's no constant correctness on this. Alright. So that's adding 15 to the pointer's location, which is defaulting to num, and which equals 115, by the way. I don't know what its address is. Right output. I could just step into this function, but okay. What the fuck is this up for? Huh. so this must be another section. Now we're talking about character arrays. And pointer to letters, it's a character pointer. Now with a character pointer, you can point to any size technically. So according to Chili, you can't go wrong with a character pointer. Because it's just byte wide, so it's a good pointer to probe memory with. Okay, ABC pointer letter is going to be an address, I would think. Oh, it's not actually, because now we're talking about an array, so but since it's a character array, it does recognize the size of the array. So when it comes to pointers and their character pointers, they will read just like a regular array will, until the end it hits a null character, end of line character. So if you actually use the dereference operator, you can see it just printed A, so at the exact place it's pointing at in the array. But otherwise, if you access a character array like this, it will keep reading until it hits that null character. So that's one difference between a character pointer and just a regular pointer, or a pointer of any other type. It'll behave like a character array, basically, which is, again, a pointer, just a slightly specialized version of a pointer. Okay, so anyway, it's the pointer's address, what it's pointing to, the referencing section. Okay, and this is where I talk about, address referencing. And a lot of this stuff's kind of pointless, because references, don't make sense at all to use outside of function calls. Because when you send something to a function, sending a reference to it makes sense, but otherwise, it's just used as an alias. So another name, a nickname for a variable that's already in memory, and you can't change it. You can't repoint it like you can a pointer. So outside of just passing values into functions, which I'm sure we're going to do a lot of here, it just really doesn't make sense to actually use references for any other reason. The address of operator. You just use that to, but as far as variables are concerned, only use this as an RHS value, right hand side, not an LHS like we do here. There's just no reason to, unless this happens to be an input to a function, like you see down here, because like I said, we're passing it by reference. Now, interesting thing is, we are creating, okay, this is expecting a pointer into it, but I think you can pass it a an address of too, and you can actually. See, with this, I can just pass it the variable name without an address, but this pointer, I either have to pass it an actual pointer, or I can pass it the address of a variable. And that'll work too, but I have to put the address of operator in the calling function. So I know I have some code in there in here somewhere, in one of these programs that demonstrates that. Let's see. Let me just step into it. Oh, damn it. Step out of this. printing out our addresses right here. Okay, sending in this reference function, a variable, and I didn't need to put address of because it's already got that in the input of that function. Now write output and compute triple, which I don't see compute triple used here, but void oh yeah, this kind of shit's kind of hard to follow. But it's kind of necessary if I recall to do something like this, but I don't think you need to though. I mean, I think I can just set, all I got to do is set my function pointer to the name of that function, but it's still got to be declared as that type of function, so this is the declaration for it, and I think that is proper. I mean, I think that's the only way to do it. So in other words, you got to have the same return type. Okay, here's the name of the pointer. Okay, and here is what the function, in this case this, expects. So let's say equals reference function. Okay, so what does that mean? Right there, reference function. So, you do have to declare the pointer with return type, okay, and then the type it takes in its parameters, and then just set it equal to, reference function, the name of the function, with no parentheses on it, because that's a function without parentheses is in of itself a pointer, but the reason we have to do this is because of the types that we got to deal with, so it's got to be set up that way. So anyway, you can pass that, and that'll go to that function, and just bingo. So, and it's a void type, so it's not returning anything. But it did, accept an address of on it, so that we'll have renamed, redefined that function. So, just like that. So, alright, output accepts the pointer as the input, so we are declaring a pointer as a substitute on this. Okay, we're going to be passing it a different, one of our earlier pointers, I think. So So that concludes the video on pointers.